21 and 22. And then 1, 2, 4, and 6. The one who finishes 21, kindly raise your hand and answer for it. Anybody for 21? Yes, anyone, students? Yes, Suhani, Chanani, Kati, Parthui, Sanchana, Sneha, Sona, Sparsh. Sona, today Yana is absent.
Yes, I don't think she's here.
Yeah, she's not there today. Vidhi NR, I don't know from where she is. Who is this Vidhi 0290? Vidhi, are you there? Kindly reply. Vidhi, are you there? Kindly reply. If you're not replying, you are not there into the lectures. Okay, two students have raised hands. It's Sneha and Chanani. Yes, Sneha, can you answer for it? Sneha?
Yes, sir.
Bolo.
Sir, first you will read the question or should I start?
Yeah, tell me.
Sir, so in this, it is given that a long horizontal rod has a bead which can slide about along its length and initially placed at a distance L from one end A of the rod, and the rod is set in angular motion about A with constant angular acceleration alpha. If coefficient of friction between the rod and the bead is mu and the gravity is neglected, then the time after which the bead starts slipping is. So, sir, in this case, since it's given that the gravity is neglected, the normal reaction force in this case would be provided by the tangential force Ft, because your gravity is neglected, so mg would not, which will not consider the weight in this case. and your Ft would be equal to the normal reaction force between the bead
How
and
do you come to the conclusion that normal reaction force is equal to the acceleration the force tangential?
Sir, because here they have given that the gravity is negative. So the normal reaction force has to be provided by the tangential force in this case.
Okay, where is the direction of tangential force over here is because this is the bead I'll consider. The bead is over here and the bead is at a distance L from the axis of rotation at point A. So where is the tangential force you'll consider?
So the tangential force would be perpendicular to the surface of the rod.
Absolutely correct. So I can consider this as the tangential force. Are you getting it? That's how we consider the normal reaction force will be directed vertically upwards. But since we neglect the effect of gravity, so this force I'll consider will be balancing in this direction we consider. Students, effect of gravity is not considered over here. And that's the entire problem student is hidden in this part only. Once when a student gets this knack, you can get it. Okay, carry on, Sneha. Normal reaction force is force tangential. What's the formula for force tangential?
Sir, it would be mass into the tangential acceleration, which is equal to mr alpha or
Okay, that
ml
is
alpha in
correct.
this
You are
case.
absolutely correct. Because the body is set to rotate. When the rod is set to rotate, the body is going to perform circular motion and it gets a tangential force. Okay, now.
So now we have to consider the friction force in this case. Frictional force, that's the force of limiting friction. So we consider that would be equal to mu n in this case, which would be equal to mu into ml alpha.
Okay, remember this force of static friction. Why do we need to go for positive? What exactly force of static friction is provided over here? What exactly this force is actually providing you? Force of static
Sir,
friction is providing you.
yeah. So this is providing the centripetal force.
Absolutely correct. Students, ध्यान से सुनना. जब ये देखो, ये सोचो कि ये रॉड है. Please everybody, okay, ये रॉड है और ये एक्सिस है. बीड उसके ऊपर है. जैसे तुम रॉड को रोटेट करोगे, are you getting it? And when the omega, see, they're saying it alpha is constant. Students, if alpha is constant, can you tell me what exactly the graphical representation of omega versus time? It will increase.
It would be a straight line passing through center.
Origin at an angle of 45 degree. Alpha क्या है? Sir, alpha constant है. यानी वेलोसिटी बढ़ रही है कि नहीं बढ़ रही है? हाँ, बढ़ रही है. तो अगर सर्कुलर मोशन का पाथ बढ़ रहा है, वेलोसिटी बढ़ रही है, तो what exactly this bead can be thrown away. Yani the bead is made to hold and the bead is holding onto the rod and it's performing circular motion and the cause for it is force of static friction, which is a real force. उसकी वजह से bead अभी तक hold पे है. लेकिन वो tangentially चला जाएगा at a certain speed. That means after a certain time, when the speed increases, it might go tangentially away. They are asking you after what time? At what time the bead has been thrown away? क्या ये पार्ट क्लियर हुआ? The explanation part to all of you. Please, is the explanation part is clear to all of you all? Think as if in
Yes,
this
sir.
case, please try to understand this. Think in this manner that you have a ceiling fan. Students, ये सोचो ना कि ceiling fan को पकड़ लो. ये जो rod को blades of ceiling fan पकड़ लो. Everybody ध्यान से सुनना. Blades of ceiling fan पकड़ लो और उस blade के ऊपर you try to place an object. Okay, और फिर gradually तुम fan को on करो. पहले fan को 1 पे रखोगे, तो it will go with an angular velocity. लेकिन क्या ध्यान से सुनना, does that body gets slide away? Does the body goes tangentially out? No. क्योंकि जैसे जैसे तुम स्पीड बढ़ाओगे, क्योंकि अभी वो बॉडी tangentially out नहीं जा रहा है. क्यों नहीं जा रहा है? Force of friction है. Friction provides the necessary centripetal force for it to perform use here onto the blade and it's still in motion. जैसे जैसे तुमने regulator का speed 1 to 2, 2 to 3, 3 to 4 करोगे, तो what happens? You are increasing omega. समझ में आ रहा है? Omega is increasing, alpha remaining constant. So now what is going to happen? Now what is going to happen? Sir, अभी force of static friction कम हो जाता है, तो ये कम होगा. समझ में आ रहा है? तो उस ऑब्जेक्ट के ऊपर एक तो वेट का फोर्स एक्ट होगा, नॉर्मल रिएक्शन फोर्स होगा और एक टेंजेंशियल फोर्स एक्ट होगा. लेकिन ये प्रॉब्लम में स्ट्रिक्टली बोला है कि वेट को तो कंसीडर करना ही नहीं है, इफेक्ट ऑफ ग्रेविटी है ही नहीं. तो दो बैलेंसिंग फोर्सेस किसको तुम लोगे? तो तुम्हारा नॉर्मल रिएक्शन फोर्स को आई कैन इक्वेट इट टू द फोर्स टेंजेंशियल. What is normal reaction force? Force tangential. Force tangential is equal to mass into acceleration tangential. What is tangential and acceleration? R into alpha. Radius of the circular path. क्या ये पार्ट क्लियर हुआ सबको?
Yes, sir.
Yes.
Everybody, please don't just blindly sit or sit mum. If you're not able to understand, speak it out right now. Shona, I'm telling you, if you don't speak it out, the rest of the students also, please do speak it out. Don't just blindly take it. Okay, Vidhi. I got a message from Vidhi. Okay, students. So now carry on. Sneha from here.
Yes. Yes, sir. So now we can substitute the force of static friction. It would be equal to mu n is equal to the force of centrifugal, which is equal to mr omega square, ml omega square. So mu s into, we can substitute the value of normal reaction that we got from the equation.
M into 80, and that is L into alpha.
Is equal
Okay,
to
then.
ml omega square.
Okay, then.
Sir, then we can write omega in terms of alpha, since it is given that the alpha is constant, which means constant angular acceleration. We can use the equation of omega final is equal to omega initial plus alpha into t. Here, initial omega is equal to 0, since
Because
it's
the
at
body
rest initially. So alpha is equal to, omega is equal to alpha t.
Okay.
So we can substitute the value of omega as alpha into t in the equation there. So when we substitute the value of omega as alpha into t, we can cancel out the rest of the remaining terms, and we get time is equal to the square root of mu by alpha.
Okay. Now suppose if I happen to go for alpha, alpha will be equal to what? Will be omega square by mu. What is the answer to be given in terms of mu and alpha that's given, na? Okay, so I have to substitute omega. I have to substitute omega. So what exactly omega will be over here? What is omega,
Alpha
student?
t.
Okay, if I take square root, what exactly omega will be equal to? Root of mu into alpha, is it?
Yes, sir.
Mu into alpha is equal to omega square. So what is omega? Under root mu alpha. So instead of omega, can I write under root mu into alpha upon alpha? Can I take alpha within the root sign? So what exactly this will be? Mu into alpha upon alpha square. What's my answer? Which option is this?
Option A.
Students, क्या ये clear हुआ?
Yes, sir.
Janani, were you solving in the same manner, Janani?
Yes, sir, I did it in the same manner.
Very good, Janani. You're from Kharghar, Janani?
No, sir, I'm from Koparkenne branch.
Koparkenne branch. Oh my God, so far away. Okay. Please, the rest of the students, what about Meera? Are you getting it? Naina, are you getting it? Om? Om,
Yes,
समझ में आ रहा है? Parthvi, are you getting it, Parthvi?
Yes, sir.
You're sounding very low. Pranshu, Priyanka? Pranshu, Priyanka? No reply. Sanjana, what about you?
Yes, sir.
Yes, sir.
Okay, South? Soumya?
yes, sir.
Yes, sir. I got it.
Okay, fine. Tisha, Udit?
Yes.
Gauri? Sparsh, what about you, Sparsh?
हाँ सर समझ गया.
Okay, fine. स्टूडेंट्स यानी ये ध्यान में रखना स्टूडेंट्स, एक सिंपल एग्जांपल, इसको समझने के लिए तुम रॉड का एग्जांपल निकाल दो, तुम पंखे का एग्जांपल ले, उसके ऊपर ऑब्जेक्ट रखा हुआ है और एक सिंपल कंसेप्ट ले लो स्टूडेंट्स. अगर तुमने पंखे को एक पे रखा है तो ऑब्जेक्ट उसी के ऊपर है ना, यानी जब ये पंखा रोटेट कर रहा है तो वो ऑब्जेक्ट क्या परफॉर्म कर रहा है? यूनिफॉर्म सर्कुलर मोशन परफॉर्म कर रहा है. यानी यूनिफॉर्म सर्कुलर मोशन के लिए मुझे फोर्स सेंट्रीपिटल की जरूरत है. अभी वो सेंट्रीपिटल फोर्स उसको कौन प्रोवाइड कर रहा है? तो तुम बोलोगे सर एक फ्रिक्शन क्रिएट हो रहा है उस ऑब्जेक्ट और ब्लेड्स के ऊपर. तो फ्रिक्शन उसको सपोर्ट कर रहा है और वो उसको उसी पोजीशन में रहने दे रहा है ना। लेकिन जैसे जैसे तुमने पंखे का स्पीड बढ़ाते गए तो व्हाट हैपेंस इन दैट केस, तो फ्रिक्शन कम होना शुरू हो गया। एक टाइम पे तुम्हारा पंखे का ब्लेड का स्पीड इतना हो गया कि क्या हुआ, द ऑब्जेक्ट फ्लाइज ऑफ, इट गोस टैंजेंशियली। नाउ नॉट कंसीडरिंग द वेट का मतलब ये तुम्हारा हिंट था, n इज इक्वल टू टैंजेंशियल फोर्स, बाकी सब exactly as it is. And we use the kinematic, rotational kinematics. V is equal to U plus AT. Initially is rest. Then I substituted omega over here in terms of this root, put it within the root sign, you'll get your answer accordingly. When you get these kind of questions, students, this becomes your formula. Some students, what do? They remember this as a formula. And they put down the statement in the books. If for problems based onto a bead onto a rod, neglecting gravity, okay, where normal reaction and tangential force are given to you, and these two graphs they draw it, then time taken to fly off is under mu by alpha. Same thing, I can give a problem onto the fan. So some students will remember the formula directly and they keep in mind till 2 years. 2-2.5 साल तक उनके दिमाग में वो फॉर्मूला रहता है, कभी भी वैसा कोई क्वेश्चन आया तो डायरेक्टली वो फॉर्मूला यूज करते हैं. Some students don't remember the formula. Some students they start deriving it, get the relation, and then they substitute the value. So that depends on to one person to another how exactly your approach is towards physics. Some students are good in memorizing, but you can't memorize too many things, students. तुम्हारा पूरा केमिस्ट्री है, तुम्हारा पूरा बायो है, तुम्हारा फिजिक्स, पूरा फिजिक्स है, कितना मेमोराइज करोगे? A human brain is not a CPU. It's not a central processing unit. यानी कहाँ पे तुम्हें conceptually समझना जरूरी है, लेकिन उसका मतलब ये नहीं कि memorizing is also very important. You need to know certain things and keep in mind throughout. Can I erase this, students? इसको erase कर दो.
Yes, sir.
Okay. Second. Bring it down to the 22nd now. The upper end of a string of a simple pendulum is fixed to a vertical z-axis and set into rotation. Suppose if I say I have kept this and the body is set to rotate in a horizontal plane. This is y-axis, this is x-axis, and this is z-axis. So same thing if I try to consider, अगर ये x-axis है, तो if I happen to try to draw, students, ये कौन सा axis हो जाएगा? Then this becomes your x-axis. ये क्या है? A tangential. If I happen to go for tangential, that means if I show the students, ये देखो, तो ये y-axis होगा. This is the center of the circular path. The height at which it's been made to revolve we consider is 5 meters. Okay, 5 meters is the height. This height is given to us 5 meters. Zero comma 0. Agreed? The distance, the radius of the circular path is given to you as 2 meters. So the upper end of the string of a simple pendulum is fixed to a vertical z-axis and set into motion such that the bob moves along the horizontal circular path of radius 2 meter. That's a radius, students, okay? Parallel to the xy plane, 5 meters above the origin. 5 meters above the origin. That's a plane of revolution. The bob has a speed of 3 meters per second. यानी उसका speed कितना? What's the velocity? What is the tangential velocity? तो देखो ये सब जगह पे अगर ये tangent अगर होती है tangential velocity हो जाएगा. What is the tangential velocity I'll consider will be 3 meters per second. Agreed? The string breaks when the bob is vertically above the x-axis. The string breaks when the bob is vertically above the x-axis. यानी यहाँ पे the string breaks. So can I say ये जो velocity होगा that is velocity along y-axis. With what velocity is going to be moving out? 3 meters per second. So can I say जब भी string टूटेगा, this is held by string. अगर जब ये string टूटेगा तो what exactly I'll consider will be? The bob will go parabolic and fall onto the ground. Students, it will fall onto the ground. It will fall onto the ground. In which plane? In an XY plane. Students, somewhere in an XY plane is going to strike. The path will be parabolic. समझ में आ रहा है? जैसे string टूटा, it will go tangentially and fall in an XY plane. So the string breaks when the bob is vertically above the x-axis and it lands in an XY plane. You need to find out the x coordinate and y coordinate. Where exactly it lands in an XY plane? क्या ये question clear हुआ सबसे पहले? हाँ students?
Yes, sir.
Please, everybody, is the question clear? Once again, I'm speaking about you have a rope, students, or you have a thread. The stone is over here, agreed, and you're making the object to revolve, the bob to revolve. And it's a kind of a conical type, kind of a pendulum. But the bob is performing circular motion in a horizontal plane. To what height above the origin it is revolving? 5 meters. What is the radius of the circular path? It's 2 meters. What is the velocity of the bob in that circular path? 3 meters per second. At a particular instant, just about x-axis, you cut the string. How exactly the bob is going to go? Tangentially. The path will be parabolic and will fall in an xy plane. At what coordinates it's going to fall? I'll give you a hint. When string breaks, okay, when the string breaks, students, the particle starts its motion from what coordinate, students? Can you tell me?
Sir, 2,0,5.
Absolutely correct. The bob starts from 2, 0, what you said it?
5.
Absolutely. 2, 0. ये सबको आना चाहिए, ये basic है, students. 2, 0, 5. Because it's just about the x-axis we consider. Agreed, we consider, so it starts revolving in that case. What's the velocity along y-axis we consider? What's the velocity along y-axis? Because see, look at the tangential. ये arrowhead देखो students, is this arrowhead in the direction of y-axis? तो इसको मैं
Yes,
vy
sir.
लूंगा. So what exactly velocity along y-axis I'll consider will be 3 meters per second. Now I need to find out the coordinates. One coordinate already has been known to you. You can get the other coordinates very easily, students. Okay, Sanjana, come on, answer. Sanjana's raised hand.
So we can use the equation S is equal to UT plus half AT square along y-axis.
Okay, plus half AT squared. Are you getting it? That is along y-axis we consider. So?
Yes, sir. So the displacement would be 5 meter and initial velocity along y-axis would be 0.
Absolutely correct.
And
Plus
half GT square.
Absolutely correct. So now can I say 10 is equal to GT square? So T square is equal to 10 by 10. So T is equal to how much?
1 second.
1 second. Time taken for it to fall will be 1 second. Okay, now?
So after that, we can use normal equation that speed is equal to distance upon time for the x-axis. So it get the range to be 3 meters.
Velocity along y-axis we consider. So it's 3 into 1. So what exactly it will be? 3 meters. And can I say you got the y coordinate as how much? 3 meters.
3 meters.
What about the x coordinate? What is the x coordinate?
So it's already given.
It's 2 meters.
2 meters. Agreed?
Yes, sir.
How come you get 2 meters? Tell me.
Sir, because when it broke, when the string breaks, it was initially vertically above the x-axis. So 2 meter, it is the initial coordinate of the bob.
Absolutely correct. Students, very clearly the statement says that the string is made to break just above the x-axis. So its x coordinate remains the same we consider. That is 2 we consider. Y will be 3. So now if I happen to consider what exactly we take it as, your x coordinate is 3, 2, y coordinate will be 3 in this case we consider. So what exactly your answer for this will be? 2, 3. क्या ये clear हुआ सबको?
Yes, sir.
Please, is it clear to all of you all? Sanjana has done it, but what about the rest of them?
Yes, sir.
Yes,
Okay. Sneha, what about you, Sneha? Clear?
yes, sir.
Okay. Suhani?
Yes.
Okay, fine. Parthvi?
Yes, sir.
Yana, why you're late, Yana? Why you entered in right now?
Sir, I thought that the lecture is of 4 o'clock. I mean,
Oh my-
4:30.
Who told you?
I thought so like that. So I just saw like right now that it's of 3:30, so I joined.
Oh my God. Students, but the lecture timing was 3:30 only, no? Huh, students?
Yes, it was 3:30 only, but from last few lectures it was 4:30, so she might be
No,
taken.
no, no. Even in this week, you are having other lectures at 4:30, but my lectures is kept at 3:30, isn't it?
Yes,
See your
Yes,
sir.
time.
sir.
4:30
Yes,
है कल भी शायद 4:30 है तुम्हारा लेकिन आज 3:30 ही है because I have a schedule just after yours. That's the reason. या ना सो रहे थे?
नहीं एक्चुअली मैं देखा नहीं, मैंने लगा 4:30 का है.
सोहना ने फोन किया ना तुम्हें, है ना सचिव?
नहीं नहीं.
Okay, fine. Okay, students, now solve the first one, second one, fourth one, and sixth one. Page number 95. Can I erase this, students? इस पे erase करूँ मैं? Students, can I erase this? South, can I erase this?
Yes, sir, I have written it.
लेकिन समझ में आया तेरे को?
Ah, sir, I paid attention when you were explaining.
Are you sure?
Yes, sir, I understood.
Okay, give me the answer for the first one. Anyone? It's a question of IIT 1974. NEET students should not, but such kind of questions are easy for one to crack. शायद तुम कर सकोगे. A sphere of mass 200 grams is attached to an inextensible string of length 130 centimeter, whose upper end is fixed to a ceiling. The sphere is made to describe a horizontal circle of radius 50 centimeter. Calculate the periodic time of this conical pendulum and the tension in the string. I'll draw the diagram for you, students. Is attached to an inextensible string of length 130 centimeter, whose upper end is fixed to the ceiling. The sphere is made to describe horizontal circle. And students, it's a question based on the conical pendulum. The one which we did right now also, students. So now when you see over here, एक sphere है जिसका mass is given to us how much? Mass is given to us 200 grams we consider. Is attached to an inextensible string of length 130 centimeter, whose upper end is fixed to the ceiling. The sphere is made to describe a horizontal circle of radius of 50 centimeter. Now, when you look at the diagram, students, can I say this becomes the plane of revolution? हाँ students?
Yes, sir.
ये होगा तुम्हारा plane of revolution हो जाएगा बॉब का या बॉडी का. यानी ये क्या था सर? ये तो सेंटर है. ये क्या है? ये इंस्टैंटेनियस पोजीशन है. ये क्या है सर? ये तो रेडियस ऑफ द बॉब है. रेडियस ऑफ द सर्कुलर पाथ है. एंड व्हाट इज द रेडियस ऑफ सर्कुलर पाथ गिवन टू अस? 50 सेंटीमीटर. तो मुझे ये बताओ स्टूडेंट्स, ये जो 130 सेंटीमीटर है, रेडियस इज 50 सेंटीमीटर, ये जो 130 सेंटीमीटर है वो क्या होगा? इज इट
Slant height.
Length of the string.
हाइट? स्टूडेंट्स, ये होगा तुम्हारा L और ये होगा तुम्हारा परपेंडिकुलर हाइट फ्रॉम द प्लेन ऑफ रेवोल्यूशन, and this angle is 90 degree. Can I say the bob or the mass is at an angle theta with the vertical? Agreed?
Yes, sir.
Yes,
Now,
sir.
if I happen to go for the relation, can I consider your cos theta will be adjacent upon hypotenuse? Cos theta is h by L. Yes. I can use different trigonometrical term. What exactly sin theta? Then sin theta will be equal to what? It's opposite upon hypotenuse. What is tan theta? Is opposite upon adjacent. Now that depends on you. तुम्हें क्या use करना है? I don't know about that. जो तुम्हें use करना है तुम use कर सकते हो, लेकिन तुम्हें पूछा क्या गया है? Find the period, time period of revolution of a conical pendulum. And the next is tension in the string. Let us say time period is capital T, students. Where is tension in the string? I'll consider will be. So I'll go for T complement. Tension. Can anybody now answer for this? T dash stands for tension, capital T stands for time period.
So we can use the formula time period is equal to 2 pi square root of L cos theta by G.
T is equal to 2 pi under root L cos theta by G. That's what you mean to say?
Yes, sir.
Absolutely correct. That's a formula for time period of revolution for a conical pendulum. But is cos theta known to you? H by L?
No, sir.
So
Can
we
you
can
find out
find
H
it.
by L?
Yes, sir. Yes, sir. We can get
At
it.
theorem of particulars, can you get it?
So instead
Yes,
of
sir.
L cos theta, we can write H also. So we don't have to.
Absolutely
Yes,
correct.
sir.
Nothing. What exactly L cos theta we can write in terms of H? Like in H दिया ही नहीं है, you can consider in terms of H, you can find out Pythagoras की हिसाब से you can get your answer. So T is equal to 2 pi under root. What is cos theta? Adjacent upon hypotenuse. So L cos theta को can I write on H by G? Can I get the value of H? Yes, it will be what? Under root L square minus R square. Can I substitute this H back over here?
Yes, sir.
Yes.
Everybody, is it clear to all the students?
Yes.
Yes, sir.
Yes, sir.
Now can you find out the tension in the string? Tension कैसे निकालोगे बताओ? Students, do you remember when I did conical pendulum with y'all, I derived tangential velocity का formula. अगर याद हो, if you remember, do anybody remembers the tangential velocity for a bob moving in a circular path for a conical pendulum? What was the formula?
Under root RG tan theta.
Very good. Who's this? Suhani. Very good. And students, Suhani and Sneha are the two people who are consistently answering at the mirror or branch. Absolutely correct, पार्थवी. तो बोलते कि नहीं हो पार्थवी, हम टेंशन को रिजॉल्व करेंगे. तो हमें ये जो डेरिवेशन किया तो टेंशन को हमने रिजॉल्व किया था ना. तो देखो ना, टी डैश ये है, तो अगर मैंने टी डैश को रिजॉल्व किया तो एक यहाँ पे होगा और एक सेंट्रल की तरफ जाएगा. ये थीटा है तो ये भी थीटा होगा. तो ये क्या हो जाएगा सर? ये होगा टी डैश कॉस थीटा, जो किसको बैलेंस कर रहा है? वेट ऑफ द बॉब, क्योंकि तुम्हें मास तो दिया है. और ये कौन सा फोर्स होगा सर? ये होगा फोर्स ऑफ सेंट्रीपिटल. नाउ व्हाट विल कंसीडर? What will consider? You'll say, sir, can I take T dash cos theta is equal to mg? Why not? T dash, what is cos theta? What is cos theta? So cos theta is h by L into mg. Can I get tension? Students, can I get tension over here? Is
Yes,
mass
sir.
given to you?
Yes, sir.
इस ग्रेविटेशनल एक्सेलरेशन ऑन टू, यानी अगर मैं इसका एकदम करेक्ट आंसर निकालूं ना स्टूडेंट्स इन एमके सिस्टम, तो लिसन केयरफुली. थीटा, कैन यू टेल मी व्हाट इज h? If I try to solve it, can you get the answer for h over here? Under root L square and 130 the whole square minus 50 the whole square.
120 centimeters.
120.
120 आ रहा है, perfect root आ रहा है.
Yes, sir.
Yes, sir.
Okay, 120 सेंटीमीटर, तो मीटर में कितना होगा स्टूडेंट्स? How much will
0.
be in
Sorry, 1.2.
1.2 मीटर हो जाएगा स्टूडेंट्स. यानी देखो ये h को मैं if I happen to go for t dash is equal to what? mgl by h. So t dash is equal to mass कितना है? 200 grams. Write down into kilograms. G is 9.8. Length is how much? 1.3 meter. And height is how much? 1.2. Can I get the answer for tension in Newton? Students?
Yes, sir.
क्या ये क्लियर हुआ सबको?
Yes, sir.
Yes, sir.
Okay. Now please go ahead with the second one, fourth one, sixth one. साउथ समझ में आ रहा है कि नहीं आ रहा साउथ?
Can I solve this one?
तूने सॉल्व कर भी दिया तो बताया कि नहीं? अभी सेकंड प्रॉब्लम तू ही सॉल्व करेगा.
Yes.
साउथ अगर तू
Sir,
सॉल्व
I
नहीं
completed half.
अगर तू सॉल्व नहीं किया तो मैं लेक्चर कंटिन्यू नहीं करूंगा, मैं बंद कर दूंगा लेक्चर. अच्छा है ना तेरे लिए? बहुत सारे स्टूडेंट्स आएंगे, बहुत सारे स्टूडेंट्स. क्या बात है सर, हॉलीडे, एकदम हॉलीडे हॉलीडे हो गया. हाँ सर, आप साउथ को ही पूछो अभी, और अपने प्रॉमिस अपने वर्ड्स पे कायम में रहना. साउथ ने आंसर नहीं दिया तो लेक्चर्स बंद कर दोगे. साउथ अभी आंसर दे.
So 1 minute.
Yeah. And Parthiv, when you knew it that you had to resolve tension, then why didn't you answer? Why didn't you raise your hand? Parthiv. Okay, can I erase this, students?
Yes, sir.
Okay, fine.
Yes, sir, I have done.
Who's this Sanjana Panda? Who's this new student coming in?
Sir, it's me only.
Sanjana only.
It's you only, Sanjana.
Yes, sir.
Okay, your name is Panda.
Yes, sir.
Okay, क्या बात है. तो तुमने दो डिवाइस यूज किया है संजना?
हाँ सर, वो एक्चुअली बीच में डिस्कनेक्ट हो गया था ना, तो वापस ज्वाइन.
Okay, fine. So I'm waiting for you. Second one.
Sir, I said you have done it. I'm ready to give the
Chalo, answer. Bolo.
Sir, we will apply the brake instantly. The reason is because sir, it's a numerical actually, so you'll need to write. Or shall I say to you?
क्या?
Sir, we will apply the brake instantly. This is the answer.
Why you'll apply brake? What's the reason? The driver of a car traveling at a speed suddenly sees the wall of at a distance r directly in front of him. To avoid collision, should he apply the brake or turn the car sharply away from the wall?
So he should apply a brake. It is because, sir, when he applies the brake, he will cover some distance, which is equal to x. I'm assuming it as x. So the kinetic energy is equal to half mv square. Kinetic energy. So half mv square is equal to fx. So therefore, sir, on solving, we will get as x is equal to mv square upon 2f. But sir,
what you said it once again? Say it once again. Please make your mic more clear and take it. Be loud and clear. What are you saying yet? Repeat.
So when he is going in a straight line,
Hmm.
so
He is
then
applying brakes at point A, and the distances from the wall are.
so that distance, sir, I assume that x.
Okay.
So sir, when he is moving in a straight line, that is equal to half mv square. And when he applies the force, that is retarding force,
Hmm.
so that is equal to fx.
Retarding
Half
force.
mv square is
So work done to overcome the force
work
of
done.
retardation is F into X.
Yes, sir. So
And
kinetic energy is equal to work done. So half mv square is equal to fx.
oh,
So therefore, from this we get the distance is equal to mv square upon 2s.
so F is equal to mv square upon 2x. Now,
Sir, I took distance, x is equal to mv square upon 2s, but that is also true. So, but now if it takes a turn, so that distance force is equal to mv square upon r. This formula we'll
hmm,
use,
hmm,
and thus we get radius that is equal to mv square upon s.
hmm.
So on equating and taking these two equations, mv square upon 2s is equal to mv square upon s. We get x is equal to r by 2, sir.
Okay, X is equal to R by 2.
Yes, sir. So, sir,
Okay,
therefore,
basically
if
you're
we
trying to
apply the
equate,
brake,
you're trying to equate this with centripetal force.
yes, sir.
Okay. Now,
So we get x is equal to r by 2. So, therefore, this car will not collide to the wall, and at half distance only this car will stop if we apply the brake. But if it takes a turn, then there are chances of colliding with the wall.
absolutely correct. Students, did you see it? Students, have you got it? What exactly he tried to work out with it? If we consider, let us say that the brakes are applied at a certain distance, we consider, let us compare X with R. Students, whenever when the person is seeing a rigid wall in front of you and he applies brakes instantly, applying brakes is retardation. Are you getting it? That means there is force of friction acting. At that instant, of course, the body will perform circular motion. Students, sudden brakes, change in velocity will make a particle to perform an arc motion. Students, listen carefully. Brakes are applied. Brakes are applied. It is always said that whenever you have turning, students, अगर suppose ये road सीधा जा रहा है, ये road सीधा जा रहा है, and all of a sudden you have a turn in a particular path of a road, we consider there is change in speed. The speed will certainly increase. From straight to circular, you will try to increase because the direction of velocity changes in that case. So yahan pe, that is why we say that whenever from straight road, if you're trying to go for a turn, you'll always come across a speed breaker. अगर तुम ध्यान से रोड पे ट्रैवल करोगे ना स्टूडेंट्स, ध्यान से सुनना, whenever you try to travel on good roads, स्टूडेंट्स ये ध्यान में रखना, जहां पे भी टर्निंग आएगा ना, शार्प टर्न्स होते हैं या टर्न होगा, ये मार्क करना स्टूडेंट्स, उसके पहले हमेशा स्पीड ब्रेकर होगा. Because if I don't put the speed breaker, any car when goes on a circular path will gain velocity in that case. And if it gains velocity, it's going to cover some more distance. Are you getting it? It'll cover some more distance. Now, suppose if I look in this case, the body is moving with certain speed, you applied brakes at this point. So the work done by the retarding force is given by the formula W is equal to F into X. This work done is because of the kinetic energy possessed by the car. So half mv square is equal to F into X. Your retarding force is actually the cause of centripetal force because that provides the necessary force of friction we consider, and that's a force. So mv square by 2x, and that is equal to mv square by r. So what exactly? X is equal to r by 2. That means when you're trying to apply brakes at point A, students, your car will halt. Your car will halt. If I take x is equal to r, your car will halt at r by 2 and will avert collision. Collision is averted. लेकिन अगर तुम्हें brakes नहीं लगाया at point A, you move with a certain and then try to take a turn. What happens? The speed will increase further on sharp turns. And that will certainly have head-on collision over here. क्या ये part clear हुआ, students?
Yes, sir.
Students, is it clear to all of you all?
Yes, sir.
Just hold up. Students, can I erase this?
Yes, sir.
The next one, 4th and 6th.
Sir, I guess we have already solved the fourth one.
Which you've done?
One is
Oh, that is tangential and centripetal, isn't it?
Yes, the
Yes,
net
sir.
acceleration.
Okay, fine. Do the 6th one then.
Okay, answer.
Yes, who's answering?
Suhan.
right.
ऐसा होता अभी एक मिनट हाँ. Let Khyati answer.
Yes, sir. Can I read the question as well?
Yes, read the question once.
Find the maximum speed at which the car can turn round a curve of 30-meter radius on a level road if the coefficient of friction between the tires and the road is 0.4 and g is given as t meter per second square.
Okay.
So the formula of Vmax is under root mu Ig. So we can apply that. Mu is given as 0.4, R is 30 meter, and G is 10 meter per second square.
Absolutely correct. Students, the formula what she's trying to give you is B is equal to under root mu R. Okay, so V is equal to under root mu R. We consider is a coefficient of friction given to 0.4. Is the radius given to you 30? Yes. And G is 10. So 4 into 30. So that's root of 120. Agreed? Can I? Now, students, let us go with new topic, students. Okay. System of particles, students. When you're speaking about system of particles, students, first of all, now please pay attention, students. Okay. We'll go for system of particles, and that is we consider first concept we consider is your concept of center of mass and center of gravity. Students. Now, students, what exactly can anybody tell me what exactly center of mass का मतलब क्या है, students? Okay. Center of mass का मतलब क्या है और center of gravity का मतलब क्या है? Yes, anybody?
Sir, can you repeat what you just told?
I asked you what exactly the difference between center of mass and center of gravity.
Oh, okay.
Yes, Kathy, you're raising your hand. Kathy?
Sir, that was for previous question.
Okay, fine, fine. Anybody?
Sir, I have 1 point of differentiation between them.
Okay, 1 point of differentiation.
So
Okay,
for the
Bono?
center of mass, it is related, means it is with respect to the object or the body, whereas the center of gravity is with respect to the ground or earth.
What you said, center of mass is with respect to what?
With respect to the body or the object.
Okay, with respect to the matter of the body or the amount of matter possessed into the body depends more precisely on the amount of matter and the shape and size of the body. Whereas center of gravity, we speak about it, depends on the alignment of constituent particles inside the body with respect to the gravitational force we consider. So what is the difference between the two? Listen carefully. First, we go for center of mass. Yes.
Sir, can it be like the center of mass is a point at which like the distribution of mass is equal in all directions and it does not depend on gravity, and the center of gravity is a point where the distribution of weight is equal in all the directions and it depends on the gravitational field.
So mainly what exactly? यहाँ पे भी constituent particles है, यहाँ पे भी constituent particles है. Agreed? यहाँ पे independent of gravity है, यहाँ पे dependent on gravity है. That is all. Let us make it more easier, students. ध्यान से सुनना. Suppose if I happen to give you a plane surface, and over here also I'm giving you a plane surface, students. And now if I happen to give you a rectangular block, I'm giving you a rectangular block, same size. तो मुझे ये बताओ स्टूडेंट्स, ये ब्लॉक को मैंने सरफेस पे रखा हुआ है, ये ब्लॉक को भी मैंने सरफेस पे रखा हुआ है, तो मुझे बताओ वेयर एक्जैक्टली सेंटर ऑफ मास ओवर हियर इज एंड वेयर एक्जैक्टली सेंटर ऑफ ग्रेविटी इज. Same block, same volume, same amount of matter present into it.
Sir, in the center.
So what exactly it will be? You'll say, sir, it will be the geometrical center. यहाँ पे भी क्या होगा? Geometrical center. Means what exactly I've tried to do it, students. If you look at this particular object, students, this object is made up of several constituent particles inside it. Several constituent particles are inside it. Now the answer sunna. Several particles are present inside this particular body. Same over here also. यहाँ पे भी. Lekin now students try to understand, are these particles are held in discrete manner or they are held in continuous manner? क्या ये clear हुआ students? Are these particles are held in discrete manner or continuous manner? ये तुम्हें judge करना है. Students, discrete manner का मतलब क्या हुआ मालूम है? Particles are scattered away from each other, having some intermolecular space. If I say continuous manner, that means how the particles are? The particles are very closely and compactly placed. They're very closely and compactly placed. So that is what we call as continuous manner. यहाँ पे क्या है? अगर मैंने लिया तो ये particle है, ये particle है, ये particle है. What exactly all these particles are in? discrete manner. Let us say that this particular block is made up of discrete manner. तो मुझे बताओ students, what is the total mass of this body? तो तुम क्या बोलोगे? The answer is ना algebraic sum of mass of each particle. Algebraic sum of mass of each particle, where I stands for first particle to I stands for end particle. Are you getting this, students? ये क्या है? ये algebraic sum है. किसका? हर एक individual mass का, students. अगर मैं सारे masses को add करूं, and if I go for n number of masses in that case, then I can get it equal to capital M. But when I go for continuous manner, this is in discrete manner. If I go for continuous manner, so what should I go for? So over here, simply I'll go for integration of dm. Limits 0 to capital M. What is integration of dm? Small m, 0 to capital M. What is my answer? M minus 0. What's my final answer? क्या ये clear हुआ, students? How are the distribution of particles is? Students, क्या समझ में आ रहा है? How are the particles have been distributed, everyone?
Yes. Can you repeat
Yes, sir.
it?
My dear, you try to take two objects, one to be highly rigid and one to be less rigid. Take a piece of iron rod and take a piece of chalk. Janani, thoda sa explore karo brain ko. A piece of chalk रखोगे तो particles discrete manner में होंगे. वहाँ पे intermolecular space ज़्यादा होगा.
Oh, okay, okay. Now I got
Iron
it.
block, when you take a piece of iron block, how are the atoms and molecules are more closely and compactly placed? So वो continuous manner होगा. तो अगर किसी ने पूछा, suppose अगर मैंने block chalk का बना दिया, तो what exactly the total mass is capital M? Over here, total mass is also capital M, but of course, since it's iron, this M I'll consider as M dash because its mass is greater. Its mass is greater. Your M dash will be greater than M. But of course, I'm getting mass because they are in continuous manner. That's whenever there is continuous distribution, we go for integration. But whenever it is in discrete manner, we simply sum up. We simply add the masses. Have you understood about, first of all, distribution of particles?
Yes, sir.
Whether they are in discrete manner or whether they are in continuous manner. Now let us understand COM ka matlab kya? What is center of mass? Now, when I say the answer Suna, now suppose if I take such a block, listen carefully. If I take such a block and if I apply force to this particular block, so can I say the force is applied on the system? What exactly system over here includes? Block. What does system includes? Block. When force is applied onto the block or force is applied onto the system, what happens to the block? What happens to the block? So the block will undergo motion. Is this clear?
Yes.
The block will undergo motion in that case. So what is happening, students? ये जो force तुमने apply किया है, ये force actually हो क्या रहा है, students? ये जो force है, this force is now acting on each constituent particle. Each constituent particle. समझ में आ रहा है? ये सारे forces on each constituent particle. That means all the constituent particles, ध्यान से सुनना, all the constituent particles get equal force. That means this force is distributed among n number of particles. And now all the particles are moving in one direction, covering equal distance in equal time. So can I say the velocity remains constant of all the particles?
Yes.
Agar velocity of all the particles in the forward direction constant, can I say the velocity of the entire system also remains constant? Ayana?
Yes.
So now if I say ये फोर्स जब मैंने अप्लाई किया है तो इनडायरेक्टली ये फोर्स कहाँ पे लगा है? इनडायरेक्टली फोर्स कहाँ पे लगा है? मतलब सर ये सारे फोर्सेस अगर हर एक मास के ऊपर एक्ट हो रहा है तो ये फोर्स कैन आई से इट्स कलेक्टिवली अप्लाइड एट अ पॉइंट वेयर आई कैन अज्यूम the whole mass of the body is supposed to be concentrated. Students, ये जो force है वो कहाँ पे लगा है? This force is actually distributed to all the constant particles. हर एक particle will move with a certain speed, so the entire system is going. A simple example, student ध्यान से सुनना. अगर try to go for a railway, try to go for a train, students. The engine of the train, ध्यान से सुनना, the engine of the train drags the entire compartments together. अगर suppose मैंने बोला the speed of the train, students, the speed of the train is 180 kilometers per hour. So can you tell me what is the speed of each wagon in that particular train? Each compartment of the train, that is also 180. Hi, Anna.
Yes.
Yes, sir.
What about each wheel? Each wheel of that particular compartment, is that also going with the same speed? 180.
Yes.
So can I say each wheel of that particular, each compartment, all these becomes what? Constant particles. All becomes the constant particles. Whereas the entire mass of that particular train is supposed to be concentrated. Suppose if the train has 10 number of bogies, if the train has, including the engine, it has 10 number of bogies, where exactly the entire center of mass is concentrated? Somewhere at the geometrical center. That means on the fifth bogie, or exactly the fifth bogie. So can I say we assume that the engine is trying to pull the entire mass at that particular fifth bogie, and the entire system is set to move with constant speed? That point where the whole mass of a body is supposed to be concentrated is called center of mass. The whole mass of the body is supposed to be concentrated at a point called COM. What does COM stands for? Center of mass of that particular system. Such that the effect of force acting on each constituent particles will be exactly equal to the force acting on the entire system. Or the force acting on entire system can be equal to the force acting on each and every constituent particles, equally distributed. क्या ये clear हुआ, students? Students, is this clear? Students, is it clear to all of you all? Concept of center of mass. So center of mass, students, is a point where the entire mass of the body is supposed to be concentrated, and it's independent of the gravity taken into account. Whereas what is center of mass? What a center of mass we consider is, sorry, center of gravity. This is center of gravity, students. Center of gravity, if I happen to consider CG, is the point of intersection of the diagonals of this particular solid geometrically we consider, where the entire weight, देखो students, यहाँ पे mass concentrated है, mass is concentrated. Students, the entire mass of the body is supposed to be concentrated at this point. But when I write on this with respect to mg, force of gravity, then this point becomes center of gravity. So center of gravity, students, dance suna, center of gravity is a geometrical center of a body where the entire weight of the body is supposed to be concentrated. That point is called center of gravity. This is center of mass, center of gravity. ये भी तुम्हारा geometrical center हो सकता है, ये भी तुम्हारा geometrical center है, लेकिन ये independent of gravity we consider. This is dependent on to gravity we consider. If I happen to go for distribution of mass in a continuous manner, then this becomes your dm, entire mass is m. If I apply force over here, then what exactly force? Friends, what are the net force acting will be equal to the answer sunna? Net force will be equal to what? Sir, it will be force acting on each constant particles. But can I say each particle will have same acceleration? So acceleration is constant. Can I remove acceleration constant? What is integration of dm will be? M, and m dash is the mass of the body. क्या ये clear हुआ, students?
Yes, sir.
Can I erase this part now, the lower part? So whenever somebody asks you what is center of mass, students, center of mass is the point where the entire mass of the body is supposed to be concentrated. One point you have to keep in mind is this. Second point, if you see the constant particle, if you look at the constant particles, and if those constant particles are in discrete manner, students, then we simply go for algebraic sum of mass of each particle and add them up. That becomes my total mass. If the mass are distributed, if the particles are distributed in continuous manner, then we'll simply go for integration of all the constant masses we consider. In case of center of mass, if the force is said to act on a block or on a body or on a system, the entire system, if it moves with a velocity v, then each constant particle also moves with same velocity v. With same, अगर ये entire block 20 meter per second से जा रहा है, तो ये भी 20 से जा रहा है, ये भी 20 से जा रहा है, ये भी 20 से जा रहा है. हर एक mass will go with 20 meter per second. तो उसका acceleration भी constant रहेगा. This is what I call a center of mass. But if I happen to go for center of gravity, then center of gravity is a point. We can consider the geometrical center we consider, where the entire weight of the body is directed vertically downwards. Whatever may be the position of the body, it's always directed vertically downward. That's the center of gravity. Yeah, ye clear hua, students?
Yes, sir.
Yes.
Yes, sir.
Can I erase the lower part of it?
Yes.
Yes, sir.
Now please pay attention, okay? Now, students, we will try to find out the position of center of mass for different object students. First of all, we'll go for center of mass for system of 2 particles. Then we'll go for system of large number of particles, okay? Then we'll go for continuous. Continuous bodies का मतलब क्या हुआ मालूम है? Continuous distribution of mass. Continuous distribution of mass, students. That is continuous bodies we consider. But before going for this, let me ask you this question once again, students. Answer now. Suppose if I happen to ask the students, the huge earth is considered over here. This is the center of the earth. Capital M is the mass of the earth. And this is an object placed onto the earth's surface. One more example, huge earth. This is the center of the earth. And this is the radius of the earth. The mass of the earth is huge. This is the radius of the earth. But now onto this earth, students, I'm trying to construct a pillar. I'm trying to construct a pillar whose height, the height of the pillar, is equal to 6,400 kilometers. That's the radius of the earth. Are the two diagrams clear to all of you, students?
Yes. Yes, sir.
मुझे ये बताओ students, पहले केस में, ये पहले diagram में, if this particular body is of mass m placed on the earth's surface, students, I want you to locate center of mass and center of gravity. And for this, locate center of mass and center of gravity.
So
Two
for the
different-
first case,
हाँ बोलो.
for the first case, the center of gravity will be at the base where the ball is touching the ground, and the center of mass will be in the center, in geometric center of the ball.
Okay. Okay. Anybody else? Students, can you compare the two masses? Don't you think so that the two masses are same, or can I say this I'll consider in comparison to Earth? In comparison to Earth, can I say this is a very small mass? Huh? Ayana?
Yes.
Can I consider this one? Imagine, consider this to be South. South is standing on the Earth's surface. So what do I consider? If I consider a small mass on the Earth's surface, students, I will assume it to be as what? As a point mass. Students, इसको मैं point mass में पकड़ूंगा. Point mass का concept क्या आता है? Point mass is a mass whose comparison is considered with respect to another object, and that is the Earth. in comparison to Earth. This object is very, very small. तो अगर ये point mass होगा students, तो यहाँ पे center of mass and center of gravity are concurrent, यानी they are one and the same. एक ही point है, यहाँ पे दो point नहीं होंगे. समझ में आ रहा है? They will not be considered as two different points in that case. But now suppose if I happen to go for a pillar which is constructed above the Earth's surface of a height of how much? 6,400 kilometers. It's a huge pillar. So what if it's a piece of wood, or if I say a piece of something of the other, but it is a huge one, 6,400. So now in this case, where exactly the center of mass will be? Somewhere at the geometrical center. But where exactly center of gravity? The center of gravity shifts towards the base. CG is shifted towards the heavier mass. Suppose if I happen to go for Mount Everest, students, Earth के ऊपर अगर मैं Mount Everest को लेता हूँ, if I go for Mount Everest, students, तो Mount Everest का CG will be lowered. CM, center of mass, will be slightly above. क्या ये clear हुआ for point mass object and for other masses?
But why exactly the CG is lower?
Center of gravity always shifts towards the heavier mass. Center of gravity always shifts towards the heavier mass. Now this concept already most of the students have learned it in the concept. Well, see, I'm trying to develop what, you know, यहाँ से हम किसका studies पे जा रहे हैं मालूम है ना? Rotational motion के ऊपर जा रहे हैं. Students, ये chapter link होता है rotational के ऊपर. So I'll give an example of that only. We can consider in that way. I get it. Now the answer is, students, suppose if I give you two bottles. Students, if I happen to give you two bottles, okay, listen carefully, students. ये दो bottle मैंने दिए. ये एक bottle है, या ना? Okay, ये दो bottle है. दोनों bottle को मैंने platform के रखा है, surface पे रखा हुआ. Please, everybody listen carefully. This is bottle 1. This is bottle 2. Okay, both the bottles are exactly identical in shape. I have filled up this entire bottle till its brim. Okay. लेकिन ये वाला बॉटल मैंने आधा भरा हूं. तो मुझे बताओ, where is the center of gravity of this first one? तो तुम क्या बोलोगे? या ना? Geometrical center.
Yes.
Agree? आया ना? Where exactly the center of gravity? Where is the center of mass and center of gravity? Am I comparing this bottle with the Earth? Yes. So it's a point mass. Both are concurrent. तो center of gravity वही है, center of the bottle. लेकिन यहाँ पे center of gravity कहाँ पे होगा? तो what did I say? Center of gravity shift towards the heavier mass. Shift towards which mass? Heavier mass. Now ध्यान से सुनना, अभी ध्यान से सुनना. Everybody think carefully. दोनों बॉटल है, ये तुम एक्सपेरिमेंट करना भी. दो आइडेंटिकल बॉटल्स लो, एक बॉटल को पूरा पानी से भरो और एक आधे भरना. फिर क्या करो मालूम है? ध्यान से सुना स्टूडेंट्स. ये जो बॉटल को है, इस बॉटल को तुम टेंजेंशियल फोर्स दो. Everybody think carefully. Look at the arrowhead. और ये बॉटल को भी तुम टेंजेंशियल फोर्स लो. See to it that the force applied in both the cases is same. So students, this is tangential force. Can I say this is the perpendicular distance? Agreed? I'll consider in this case also center of gravity from it. Are you getting it? The entire system we consider is the center of gravity has been shifted over here in that case. यहाँ पे center of gravity तुम्हारा shift हो गया. यहाँ पे center of gravity. Which body will have a turning effect better? कौन सा body turn तुरंत होगा? Topple कौन सा होगा? Will the first body will topple easily or the second bottle? अगर मैंने suppose उसको थोड़ा सा force दिया और छोड़ दिया, तो which one will have a tendency to topple?
First one.
What's the reason behind it? What is the reason for it? Because CG is lowered यहाँ पे students. समझ में आ रहा है? CG lowered होने की वजह से क्या होगा? The entire weight is concentrated at the bottom to consider. Whereas यहाँ पे क्या है? CG is raised. तो यहाँ पे तुमने अगर छोटा सा भी फोर्स लगा दिया तो व्हाट्स गोना हैपन, ये टॉपल होना शुरू हो जाएगा और ये टॉपल नहीं होगा. One more example we consider is where exactly the CG has been shifted. We consider. Let me go for another example. Students, have you seen the two cars? Okay. Let us go for two different cars, two Indian cars only, students. If you see one car, which is a kind of a Wagner. Students, कभी Wagner को देखा है? Not the new one. थोड़ा सा पहला वाला Wagner. अगर old Wagner को अगर तुम देखते हो, और दूसरा तुम स्विफ्ट को देखो स्टूडेंट्स, ये पीछे का पोर्शन है स्टूडेंट्स, द रेयर पोर्शन. सी दैट यू आर वाचिंग द टू कार्स फ्रॉम बिहाइंड. स्टूडेंट्स, हैव यू सीन अ वैगनर? वैगनर इज अ काइंड ऑफ अ मैच बॉक्स. अ स्विफ्ट इज ब्रॉडर, उसका बैक पोर्शन इज ब्रॉड, स्लाइटली मोर ब्रॉडर इन दैट केस. तो ये हाइट लोअर, तो यहाँ पे सेंटर ऑफ ग्रेविटी इज लोअर, यहाँ पे सेंटर ऑफ ग्रेविटी इज रेज्ड. सी दिस इज द अर्थ सरफेस, ये तुम्हारा अर्थ है. तो ये देखो, ये हाइट ज्यादा है, ये हाइट कम है. अगर ये दोनों कार को मैंने सर्कुलर ट्रैक पे मूव किया और मैंने स्पीड बढ़ा दिया, स्टूडेंट्स, दोनों कार सर्कुलर मोशन में जा रही है, दोनों कार सर्कुलर मोशन में जा रही है, और मैंने स्पीड बढ़ा दिया, एक स्पीड लिमिट से मैंने ज्यादा स्पीड देना शुरू कर दिया. स्टूडेंट्स, व्हिच कार विल हैव अ पॉसिबिलिटी टू टॉपल?
First one.
That is why cars with lower CGs can have greater speed and better contact. Have you seen the Formula One race? Friends, कभी Formula One race देखा है कभी? हाँ, कार का रेसेस होता है तो उसमें Formula One race देखा है. तो वो गाड़ियाँ कैसी होती है? क्या बड़ी वाली गाड़ियाँ होती है या एकदम the car is compressed? हाँ या ना? यानी पूरा compressed. Have you seen the person who's sitting inside? He is also actually much more in. अगर तुम देखोगे ना, कार का बेस और रोड सरफेस hardly it will be 15 centimeter away. 15 centimeter is simply scale. उतना गैप है बस. And with so high speed. क्यों? क्योंकि जितना CG लोअर होगा उतना कॉन्टैक्ट ज्यादा रहेगा, टॉपलिंग का इफेक्ट कम. Agree, students?
Yes.
Now let me speak about. You all have done, students. Laws of motion. हाँ, तुम लोगों ने फ्री बॉडी डायग्राम किया होगा, है ना? फ्री बॉडी डायग्राम किया है, तो फ्री बॉडी डायग्राम के अंदर डिड यू सिलेक्टेड फॉर एवरी बॉडी द फोर्सेस एक्टिंग? सपोज इफ आई से अ बॉडी इज प्लेस्ड ऑन द सरफेस. चलो, मैंने पूछा ड्रॉ फ्री बॉडी डायग्राम, तो क्या कैसे करते हो तुम लोग? बताओ, कोई बता सकता है? तो कहाँ से लेते? डाउनवर्ड मींस कहाँ से? From where do you?
From the center of gravity.
So what exactly the word you use? Forces were acting where? At center of mass or center of gravity? What is the word you use?
Gravity.
Center of gravity.
सेंटर ऑफ ग्रेविटी का वर्ड, सर ने ज्यादा सेंटर ऑफ ग्रेविटी का वर्ड यूज किया होगा, आया ना?
Yes, sir.
क्योंकि वो सारे ज्योमेट्रिकल शेप के ऊपर वो ज्योमेट्रिकल सेंटर पे होगा. क्यों नहीं सेंटर ऑफ मास? तुमने तभी सेंटर ऑफ मास क्यों नहीं पूछा? क्योंकि ये पॉइंट मास है, ये पॉइंट मास ऑब्जेक्ट है. ये पॉइंट मास ऑब्जेक्ट हम किससे कंपेयर करते हो? हम अर्थ से कंपेयर कर रहे हैं. तो पॉइंट मास ऑब्जेक्ट जब अर्थ से कंपेयर करते हो तो कुछ फर्क नहीं गिरता है. तो सीओम बोलो या सीजी बोलो. आर यू गेटिंग इट?
Yes, sir.
So
Yes,
the
sir.
forces are going to act from there only. तुम बोलोगे सर mg नीचे की तरफ act हो रहा है. Normal reaction force is exerted by the surface passing the center of gravity vertically upwards. ये तुम्हारा normal reaction force हुआ. ये तुम्हारा mg नीचे की तरफ act हो गया. I get it. There are force of frictions also which are trying to hold the body. वही अगर मैंने inclined plane पे ले लिया students, चलो inclined plane पे. ना ध्यान से सुनना. When we derive the formula, if you recollect students, can you give me the formula for maximum speed of a car? I'm going with my topic. Students, maximum speed of a car on a circular banked road considering friction. तो बता सकता formula क्या है? याद है किसी को? We derived this formula. Maximum speed of a car on a circular banked road considering friction. तो क्या formula था? Rg tan theta plus mu s upon 1 minus.
Mu tan theta.
ये तुम्हारा फॉर्मूला था, आया ना?
Yes.
भूल गए?
Yes, sir.
हाँ, अगर along an inclined plane, अगर along the inclined plane में लेता हूँ students, तो maximum speed के लिए कार का motion किस तरफ जाएगा, friction इस तरफ जाएगा. यानी students कभी भी ये भी MCQs है, ये theoretical MCQs है. If a car is moving on a circular banked road considering friction for maximum speed, does the friction acts upwards along the inclined plane or downwards? तुम्हारा आंसर होगा downwards. क्योंकि कार ऊपर की तरफ जा रही है, यानी वो ऊपर की तरफ रहेगी तो उसकी स्पीड ज्यादा होगी. लेकिन अगर v मिनिमम हो जाएगा ना, तो कार ऑटोमेटिकली स्लाइड नीचे करेगा और सर्कुलर पाथ में जाएगा, तो फ्रिक्शन ऊपर होगा. समझ में आ रहा है स्टूडेंट्स क्या बोल रहा हूं मैं? Everyone, please, I'm not teaching 2 or 3 or 4 students. Please, I'm not teaching 2 or 3 or 4. All the students who are into the group, are you all getting it?
Yes.
Yes,
Okay,
sir.
Yes, sir.
Parthy is not there. Parthy is there.
So I said yes.
Okay, fine. Sanjana, Suhani, Soumya.
Yes, sir.
Yes.
Okay. जब भी हमने डिराइव किया था स्टूडेंट्स, मुझे बताओ, जब भी कार को मैंने बताया था तो मैंने क्या किया था कार को? Didn't I consider car as a point mass? हाँ, मुझे अगर 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 मुझे फोर्सेस को रिजॉल्व करना था तो मुझे पॉइंट मास लेते हुए अच्छी तरह से मैंने रिजॉल्व किया था. वही अगर मैं बड़ा सा ब्लॉक दिखाता था तो थोड़ा सा डायग्राम और कंफ्यूजन हो जाता था. So what exactly I'm trying to consider? The entire mass, if I happen to consider, I'm taking it to be as what? As a point mass. And then I'm trying to go for free body diagrams onto this. So शायद तुम लोग ने भी जब भी प्रॉब्लम सॉल्व किए होंगे, अब ब्लॉक एंड वेज के प्रॉब्लम्स या ब्लॉक और इंक्लाइन प्लेन के प्रॉब्लम, कंसीडर द इंक्लाइन प्लेन ऑफ मास कैपिटल M, द ब्लॉक इज ऑफ मास स्मॉल m. तो अगर तुम कंपेयर करोगे तो ये छोटा है इससे, तो यहाँ पे तुम्हारा CG और COM क्या होगा? कॉन्करेंट ही होगा. Are you getting it, students?
Yes. Yes, sir.
So please, students, do keep in mind, center of mass is a point where the entire mass of the body is supposed to be concentrated, and it's independent of the force of gravity we consider. Center of gravity is the point where the entire weight of the body is supposed to be concentrated. Is that clear? Whenever you go for discrete manner, then we simply go for algebraic sum of mass of each particle. If I go for mass distributed in continuous manner, then we go for integration of dm we take. For a point mass, center of mass and center of gravity are both concurrent. For objects which are not of point mass, that means the mass is quite huge and comparable to the Earth. Or in terms of Earth, we consider, then in that case, your COM and CG will be different. CG always try to shift towards which mass? Towards the heavier mass. Lower the CG, the answer sunna, lower the CG of a given object, more the object will be in equilibrium. Lower the CG of in a particular object, the object will be in better equilibrium. That equilibrium can be static or can be dynamic with uniform motion. लेकिन दोनों केस में तुम्हें equilibrium मिलेगा. Are you getting it?
Yes.
Students, the center of gravity, let me speak about for center of gravity. Okay, the center of gravity, students, lies into the matter or can lie outside the matter.
Can lie outside. It can lie outside.
Okay, so center of gravity can lie into, okay, or outside the matter. Either case you can consider. ये ध्यान में रखना students. अब इसका एक best example I can consider. Okay, suppose if I say a thin uniform rod, a thin uniform wire, students, a thin uniform wire of length L. Students, can you tell me what exactly the center of gravity for this wire? कहाँ पे होगा?
Midpoint.
At L by 2.
Midpoint of
At L by 2, है ना? Agreed?
Yes.
And the entire weight of the rod is directed downwards. ये thin uniform wire है. Same wire. Now if I bend in form of a ring, same wire of length L only, okay, bend in form of a ring, then can you tell me where exactly center of gravity?
Center of the ring.
Center. Yani can I say this is center? Yani the entire weight of the ring is directed. Does it lie into the matter? No, sir. It lies outside the matter. This lies into the matter. Any center of gravity is a geometrical center, but it can lie inside or can lie outside the matter. Agar suppose मैंने boomerang लिया, students, have you seen a boomerang? Students, a boomerang.
सर ऑन
इसका
टीवी
center of
देखा
gravity. Pardon?
है सर, फेस टू फेस रियली नहीं देखा है, इन टीवी
हाँ. हाँ, लेकिन अगर तुम बूमरैंग को देखोगे ना स्टूडेंट्स, तो बूमरैंग का वेयर एक्जैक्टली सेंटर ऑफ ग्रेविटी विल बी, तो तुम 0.1 लो, 0.2 लो, 0.3 लो, ये तीनों का अगर मैं एक्सिस ऑफ रोटेशन अगर मैं लेता हूँ, तो तीनों का एक्सिस मीट्स एट द पॉइंट आउटसाइड. तो ये हुआ तुम्हारा सेंटर ऑफ ग्रेविटी. स्टूडेंट्स, डज इट लाई इनटू द मैटर और आउटसाइड द मैटर? आउटसाइड द मैटर.
Outside the map.
एग्री स्टूडेंट्स? ये सेंटर ऑफ ग्रेविटी का कंसेप्ट. Now, for example, you are climbing a mountain, students. This is a mountain. Okay. In this case, you are climbing, and over here, climb up. Are you getting it? And you are climbing down. Students, ये चढ़ान के लिए जा रहे हो, चढ़ान के लिए. मुझे बताओ, when you climb up a mountain, do you lean forward or you lean backward?
Lean forward.
है ना? यानी देखो, अगर तुम देखोगे, तो देखो, ये तुम्हारा पोस्चर है ना? अगर सपोज मैंने यही पोस्चर ऐसे रखा होता, everybody listen carefully, तो क्या होता? कहने से तुम गिर जाते, आया ना?
Yes.
टॉपल होते क्यों है? लेकिन यहाँ पे टॉपल होंगे नहीं होंगे. Why? Because ये तुम्हारा center of gravity. Students, your navel point is the center of gravity. Now see, where is the weight of the body is directed? The weight of the body is directed, students, vertically downward. But does it falls exactly in front of the body or between the two legs? Yes. फ्रेंड्स, तुम्हारा जो वेट है वो हमेशा तुम्हारे आगे की तरफ ही एक्ट होगा. एक फोर्स जो तुम्हें पकड़ के रखेगा, इट विल बी ईदर अहेड ऑफ यू, अगर तुम ज्यादा बेंड करोगे तो और आगे आएगा, या बिटवीन द टू लेग्स, एंड दैट विल होल्ड यू टू क्लाइंब अप. अगर बाय चांस थोड़ा सा तुम पीछे की तरफ चले गए, तो तुम टॉपल हो सकते हो, गिर भी सकते हो. नाउ व्हेन यू आर कमिंग डाउन, when you're coming down or climb down, we consider, so what exactly, do you lean forward or you lean backward?
Forward.
While climbing down, will you lean forward? If you lean forward, you will fall down.
No, sir, sorry.
See the force of gravity. ये तुम्हारा center of gravity है. See, you consider, it's holding you. This is mg, and this is center of gravity. This is trying to hold you in this space. So while coming down, you lean backward, and over here, you lean forward while going up. Is that clear, students?
Yes, sir.
Can I erase this now?
So 1 minute. Done, sir. You can use.
Okay. So students, center of gravity, if somebody asks you how do you define center of gravity, is a point where the entire weight of a body is supposed to be concentrated. This point can lie inside or outside the matter, whatever may be the position of the body. Whatever may be the position of the body, it will be always acting vertically downwards. The force which is acting vertically downwards from that point is called as the center of gravity. Center of mass is a point where the entire mass of body is supposed to be concentrated. Now we are trying to go for location of position of COM. पहला case किसके लिए? System of two particles. Now suppose if I give you two particles, students. Suppose if I give you, I'm speaking about the first one, students, first one. Suppose if I say this is M1 and this is particle M2, students. Let us say the two particles are at a distance apart from each other. Where exactly the center of mass will be? So हमें नहीं पता. हमें नहीं पता where exactly center of mass is. I'm getting it. The center, अगर suppose मैंने center of mass को अगर मैं locate किया, let us say that the center of mass I'm locating at this particular point. Let us say at point COM is over here, somewhere over here. And I'm taking this distance as R1 and this distance as R2. That R1, can I take it as, assume it to be as X? तो ये कितना होगा? D minus X. क्या ये clear हुआ?
Yes, sir.
Now listen carefully, students. The center of mass of two particles M1 and M2 separated at a distance D apart from each other, students. Then COM for any one of the particles, students, COM of any of the particle. Are you getting it? Its distance is inversely proportional to the mass of the particle. Students, यानी अगर मैंने mass M1 लिया है, उसका distance from the center of mass is R1. Are you getting it? So students, the distance of the center of mass is inversely proportional to the mass of the particle. This is a very, very important relation. Now I'm not putting this one. What does this R stands for, students? What exactly is R stands for?
Distance of the mass from the center of mass.
Distance of center of mass. किसका? From any of the particle. From any one particle is what? Inversely proportional to mass of that particle. क्या ये clear हुआ, students?
Yes, ma'am.
That means if the mass increases, the distance decreases. Now, if I try to use this as my mathematical relation to locate my center of mass, so I can easily get it. अभी देखो यहाँ पे अगर तुम देखोगे तो तुम बोलोगे सर इसका मतलब अगर ये रूल मैं अप्लाई करूँ तो मेरा फॉर्मूला आएगा R1 is inversely proportional to M1, R2 is inversely proportional to M2. हाँ या ना? Agreed? Students, is this clear?
Yes.
Now, if I happen to take the ratio in this case, so can I say R1 by R2, and if I remove the proportional symbol sign, the constant gets cancelled. So can I say it will be simply M2 by M1? क्या ये clear हुआ? Students? Now, what is R1? What is R1? Let us say R1 be X. Then what is R2? D minus X. Can I say this is M2 and this is M1? Are you getting, students?
Yes.
Now, suppose if I want to find out the value of X, can I get the value of X? Why not? I can get the value of X to find out the distance. अगर मुझे distance चाहिए तो M2 into bracket D minus X cross multiply and get the answer separately. लेकिन अगर तुम्हें substitute करना है तो तुम क्या करवा लो students? यही equation लेके तुम correct answer लेके आ सकते हो. बहुत easy बन जाता है students क्योंकि ratios आ गया. Now the answer is no. I'm taking the concept of properties of ratio. R1 by R2 is M2 by M1. Now suppose students, if I use componendo, so can I say R1 plus R2 upon R2 will be M2 plus M1 upon M1. क्या ये clear हुआ, students?
Yes.
What is R1 plus R2? What is R1 plus R2? D. So can I take this as D? Can I get the value of R2? Yes. Which is equal to what? M2 plus M1 upon M1. Friends, can I find out the center of mass from the second body? R2, can I find out the position of the center of mass from the second body? Yes, make R2 as a subject. What's my answer? M1 into D upon M1 plus M2. Similarly, अगर मुझे R1 चाहिए तो what is my formula will be? अगर मुझे R1 चाहिए तो what is my formula will be? It will be M2 into D upon M1 plus M2. क्या ये दोनों formulas clear हुआ?
Yes, sir.
अरे जब भी तुम क्वेश्चन सॉल्व करो ध्यान से सुना, अभी न्यूमेरिकल्स में कैसे सॉल्व करना है ये मैंने फॉर्मूला दे दिया है. अगर सपोज तुम्हें कभी भी दो पार्टिकल्स के बारे में दिया ना स्टूडेंट्स, एनी सिस्टम ऑफ टू पार्टिकल्स, and if they tell you to find out the center of mass, then how do you think the distance of the center of mass is inversely proportional to the mass of the body? Now see over here students, अगर suppose mass ज्यादा heavy है तो center of mass will be closer to that particular heavier mass. अगर mass छोटा है तो center of mass will be away. अगर मैं सपोज M1 को छोटा दिखाता हूँ स्टूडेंट्स और मैंने M2 को स्टूडेंट्स जानबूझ के अगर मैं बड़ा दिखा दूं स्टूडेंट्स, M2 is of greater mass, so where exactly the center of mass we will see more precisely towards the heavier mass, and the distance of the center of mass will be away from which mass? Lighter mass. क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
Agreed?
Yes, sir.
Can I erase this?
Yes.
Okay. So now when you speak about it, students, your formula will be equal to what? R1 by R2 will be equal to what? M2 by M1, students, you can get it. This is a mathematical relation. Suppose if I say for the two bodies of equal masses, students, अगर मेरे दोनों mass, अभी देखो यहाँ पे तुम conditions ले रहे हो students. What are the conditions? M1 is equal to M2. M1 greater than M2. M1 less than M2. तो क्या होगा? अगर M1 is equal to M2 तो कहने से R1 is equal to R2. Agreed? हाँ students?
Yes, sir.
तो यहाँ पे तुम्हारा M1 M2 के बीच में exactly center of mass will be, suppose if I take this as M1 and M2, both of them are equal, तो कहने से this is exactly midway होगा, है ना? Is this clear?
Yes, sir.
Now suppose if I say M1 is greater than M2, I getting it? M1 is greater than M2. So now if I that means if I say M2 is less than M1, if I say M1 is greater than M2, I'll put it over here. M1 is greater than M2, therefore M2 is less than M1. Therefore, can I say ratio of M2 by M1 is less than 1? Therefore, can I say R1 by R2 is less than 1? Therefore, can I say R1 is less than R2? क्या ये clear हुआ students?
Yes, sir.
Now, if I want to show it, ध्यान से सुनना, mass of the first body is greater. Mass of the second body is smaller. ये है M1 greater, M2 smaller. ये दोनों के बीच में distance दिया हुआ है. Where exactly the center of mass will be? R1 is less than R2. Where is the center of mass? Will the center of mass will be closer to M1 or far away from M1?
Closer to M1.
R1 is less than R2. Can I say center of mass यहाँ पे होगा? ये distance तुम्हारा होगा R1 और ये distance होगा R2. क्या ये clear हुआ students?
Yes.
लेकिन अगर मैंने लिया M1 is less than M2, I getting it? That is M2 is greater than M1. Therefore, ratio of M2 by M1 is greater than 1. Therefore, R1 by R2 will be greater than 1. Are you getting it? So in this case, therefore, R1 is greater than R2. So where is the center of mass will shift? Of course, towards the heavier mass, because R2 is greater. M2 is greater, so it will shift towards it. यानी ये M1 है, छोटा मास है स्टूडेंट्स, ये M2 बड़ा मास है, तो तुम्हारा सेंटर ऑफ मास किस तरफ शिफ्ट होगा? हेवियर मास. ये तुम्हारा R1 होगा और ये तुम्हारा R2 होगा. Are you getting it? R1 is greater than R2, so center of mass will be away from M1 but closer to M2. Sorry, away from M1 but closer to M2. क्या ये क्लियर हुआ?
Yes.
Yes, sir.
सारे केसेस में फॉर्मूलास तुम क्या यूज करोगे? R1 by R2 is M2 by M1. So what is the product? हमेशा जब भी तुम प्रॉब्लम सॉल्व करोगे ना, सिस्टम ऑफ टू पार्टिकल्स, आंख बंद करके स्टूडेंट्स M1 R1 M2 R2 यूज कर देना बस. जहां पे भी तुम्हारा प्रॉब्लम थोड़ा सा ट्विस्टेड आ गया तो यूज रेशियो एंड देन यूज कंपोनेंडो डिविडेंडो एंड ट्राई टू गो फॉर दैट. द टोटल डिस्टेंस माइट बी गिवन टू यू, so you know that R1 plus R2 is D and get your answers accordingly. Is this clear?
Yes.
क्या मैं
Yes,
ये
sir.
erase कर दूं? Can I erase this part? Since can I erase it?
Yes, sir.
Yes, sir.
Now we go for the second part of it. System of large number of particles. Before going for the students, इसी के first के लिए मैं थोड़ा सा example देता हूँ students. I'm just giving you certain example to get your answers, students. Let us see. Students, अगर suppose मैंने बोला है two particles मैंने दिया है, okay, this is a problem onto it. Students, two particles मैंने दिया है, एक का mass दिया है 1 kilogram and the other one is 3 kilograms, students. Okay, and they are located at, one is located at x is equal to 0 meter and other is at x is equal to 3 meter. Mera question is, students, find COM of the system. See the word I'm using it, center of mass of the system. Students, what exactly the system consists of? System consists of both the masses. यानी अगर तुम्हें n number of masses तो पूरे सारे masses को मिला के system बनता है. So now I want to find center of mass of the system. Can you get an answer for this? Yes, anybody? Come on, Akshata, Meera, Naina, Om, Pranshu, Sona, Tisha, Udit, Vidipal, Ardashini, Gauri, Sparsh, Yana, you're not answering at all. Vidhi, Vidhi, are you in lectures? Reply. Vidhi, are you in lectures? It seems you're not in lectures. Oh, very good. Prompt reply, very good. Yes, students, can you give an answer for this? Anyone? Two masses are given to you, 1 kilogram and 3 kilogram. Are placed at x is equal to 0 meter and x equal to 3. Find out the center of mass for the system.
Sir, sir, is the answer 2? Sir, I don't know if I'm right or not. I think it's 2.
Of course, it's 2. ये देखो ना, ये M1 है, इसको ले लो R1, ये है M2 और ये है R2. Are you getting it? आया ना? Is it?
Yes, sir.
यानी अगर तुम्हें दोनों मास के बीच में अगर तुम्हें डिस्टेंस बताना है तो व्हाट एग्जैक्टली कंसिडर विल बी R1 का डिस्टेंस, यानी तुम R1 का डिस्टेंस तो सेंटर ऑफ मास का डिस्टेंस, यानी तुम्हें ध्यान से देखना स्टूडेंट, तुमने M1 लिया है और ये M2 लिया है. स्टूडेंट्स, तुम्हें नहीं पता ना सेंटर ऑफ मास कहाँ पे, तो ये COM. एग्रीड? Let us take this distance as r1 और ये distance कितना लिया तुमने? r2. Agreed?
Yes, sir.
Now, how do you look at the center of mass for this? Students? What is the total? M1 कहाँ पे? Students, M1 का क्या है? यानी students जब भी तुम इसके बारे में सोचो ना, how do you judge it? You know, try to take it on x-axis ना, students. ये देखो ना, तुम्हारा प्रॉब्लम कैसे इजी हो जाएगा. Students, तुम्हारा प्रॉब्लम देखो कितना इजी हो जाता है. ये x लो, ये y लो और ये z ले लो. यानी तुम्हारा m1 यहाँ पे स्टूडेंट्स इसके कोऑर्डिनेट्स क्या है? 0,0,0 यानी ये 0.0 है. ये तुम्हारा m2 है ऑन x एक्सिस और ये मास कितना है? 3 किलोग्राम. ये कितना है? 1 किलोग्राम. ये टोटल डिस्टेंस कितना हुआ? 3 मीटर हुआ. इतने से 3 मीटर स्मॉल d है ना? हाँ स्टूडेंट्स.
Yes.
What exactly the formula have come across? The formula is what? m1 r2 is equal to m2 r1. ये formula है कि नहीं है?
Yes.
Sorry, m1 r1 very sorry is equal to m2 r2. क्रॉस मल्टीप्लिकेशन में आता है इनवर्स प्रोपोर्शनल टू. आया ना?
Yes.
तो अगर r1 को मैंने x ले लिया तो ये क्या हो जाएगा? d माइनस एक्स होगा कि नहीं होगा? हाँ स्टूडेंट्स. तो देखो m1 व्हाट इज द मास ऑफ द फर्स्ट पार्टिकल? 1. व्हाट इज r1 को मैं लेता हूँ into x is equal to m2 is how much? 3. What is r2? I'll consider is d minus x. Can I solve? So x is equal to what? 3d minus 3x I can consider in that case. Is this clear?
Yes.
So now can I get an answer accordingly in this case? Why not? D is equal to how much? I'm getting it. So I can get your answer accordingly. क्या ये clear हुआ students?
Yes.
You can get your answer accordingly. यानी कभी भी तुम क्या करो मालूम है students? Object को तुम कहाँ पे करो? X axis पे ले लो. The center of mass. And when you come across, you'll find out the center of mass is towards the heavier mass. क्या ये clear हुआ सबको students? Is this clear to all of you all?
Yes. Yes.
Okay. Students, this was center of mass का location with respect to 2-point mass. Next lecture, I'll be going with respect to what? Large number of particles and continuous bodies. Agreed? ये जो
Yes,
two
sir.
particles हैं students, that two particles you can take it along x-axis, you can take it along y-axis, you can take it along z-axis. And center of mass is a point where the entire mass of the body is supposed to be concentrated. Okay, students, next lecture will be continuing for that. Okay.
Okay, sir.
Thank you, sir. Bye, sir.
Bye.